We have a radical equation that we want to solve. We're going to start by trying to use order of operations in reverse because we are solving, so we're trying to undo what was done. This radical symbol, think of it like a grouping symbol or parentheses. So in this first part, I'm always looking outside of this radical to see if there's anything to add or subtract, then to multiply or divide, and then the radical is kind of on the same level as the exponents. So as I go through this process, I see that on the outside I have something to add or subtract. I have a plus 7. I will subtract a 7 from both sides. These on the right side, 4 and negative 7 combine to make negative 3. And then these just cancel. So the left side's left with x plus 5. I'll look outside the radical to see if there's anything to multiply or divide. There's not. And the radical itself is treated like an exponent. I need to use the same power that the radical has to get rid of it. There's no number written here in the index, so the default value here is 2, which means I'm going to take both sides to that second power. When you take negative 3 and square it, just a quick word of caution, you should know negative 3 times negative 3 is positive 9. If you're the kind of person who uses your calculator frequently, you may be tricked into thinking it's negative 9. If you get a negative 9 on your calculator, you're putting it in your calculator incorrectly. Negative 3 times negative 3 definitely is positive 9. And on the left side, the square and the square root cancel. So all that's left is the x plus 5. Now that I've gotten rid of that grouping symbol, or the parentheses, I'm going to start the process all over again. I want to get this x by itself, so I'm looking to see if there's anything to add or subtract. A 5 was added, so I'll subtract 5 from both sides. These cancel. These guys make a positive 4. And if there's an answer, it will be 4. But it's totally possible to do a problem with radicals, do all your math correctly, and have a number that doesn't actually make this equation true. So we have to check our work every time. Square root of, when I plug in 4 for x, 4 plus 5 plus 7, I'm looking to get an answer of 4. So if this does not equal 4 after I evaluate it, then there's no solution. I'm actually evaluating, so I'll do the order of operations. I'm going to treat the stuff in the radical as if this was like there's an implied parentheses here. So I'll do this calculation first. 4 plus 5 make 9, giving us the square root of 9 plus 7. The square root of 9, what multiplies by itself twice to give me 9 is 3. I get 3 plus 7. 3 plus 7 makes 10. I was hoping to get a 4. I got a 10. It's not what I needed to get, so this is actually no solution. Because the only thing that might have worked ended up not working. It didn't make a true statement. And that's why checking our work is so important. There's no errors in my work here at all. It's just the answer that might have worked didn't. Good luck.